Hypersonic flight is the next big leap in aviation, offering speeds faster than the speed of sound and leaving no trace behind other than a loud bang. Imagine cutting a flight from New York to London down to just 90 minutes. While companies like Hermeus are pushing the boundaries of what's possible, in a surprising twist, Elon Musk's SpaceX is rumored to be working on a top-secret project that could revolutionize hypersonic travel. With Musk's track record of turning ambitious ideas into reality, could his latest venture be the breakthrough we've been waiting for? What does this mean for the future of air travel and global connectivity? Join us to find out if Elon Musk's hypersonic jet defies the speed of light. The quest for hypersonic flight represents the next frontier in aviation, promising to revolutionize air travel and reshape global connectivity. While commercial planes typically cruise at around 550 miles per hour, hypersonic flight aims to achieve speeds of Mach 5, which is about 3,836 miles per hour or higher. At these velocities, a journey from New York to London could be completed in just 90 minutes, drastically reducing current travel times. Companies like Hermeus, Stratolaunch, and Hypersonics are at the forefront of this technological race. However, a surprising development has captured global attention. Elon Musk's SpaceX has unveiled the X-1, a revolutionary UFO fighter jet that challenges conventional aerospace technology. The X-1 promises to redefine air combat with its advanced technology and unprecedented capabilities. It can achieve hypersonic speeds of 4,600 miles per hour and features revolutionary camouflage technology that renders it virtually invisible to radar. The X-1's propulsion system, derived from SpaceX's Merlin and Raptor engines, enhances fuel efficiency by 30% compared to traditional military aircraft. While the X-1's primary focus appears to be military applications, its technological advancements could potentially influence the development of civilian hypersonic aircraft. The integration of such cutting-edge technology highlights the evolving landscape of global aerospace capabilities. These projects face significant challenges, including thermal management, propulsion efficiency, and the development of new materials capable of withstanding extreme temperatures. The intense heat generated at hypersonic speeds and the need for specialized propulsion systems are hurdles that engineers must overcome. Despite these obstacles, the potential applications of hypersonic technology extend beyond commercial travel to areas such as national security and space exploration. The development of safe, efficient, and economically viable hypersonic aircraft requires advancements in materials science, aerodynamics, and propulsion technology. While routine hypersonic flight may still be years away, the ongoing research and development in this field continue to push the boundaries of what's possible in aviation. Imagine a future where long-distance travel is faster than ever before, and it is possible to fly across the Atlantic Ocean in less time than it takes to watch a movie. The Concorde, a sleek and futuristic aircraft, made this dream a reality for over 27 years. Introduced in 1976, this supersonic passenger jet could fly at an impressive speed of 1,354 miles per hour, more than twice as fast as regular airplanes. This meant passengers could travel from New York to London in just under 3 hours, instead of the usual 7 to 8 hours. Despite its groundbreaking speed, the Concorde fell short of reaching hypersonic speeds, which start at Mach 5 or 3,836 miles per hour. Still, it remained an icon of aviation technology and luxury travel until its retirement in 2003. The final commercial Concorde flight took place on October 24, 2003, marking the end of an era in passenger aviation. Interestingly, the Concorde set a speed record even as it was heading to retirement. On November 5, 2003, a Concorde named G-Bog flew from New York to Seattle in just 3 hours, 55 minutes, and 12 seconds. This flight was part of the aircraft's journey to its final resting place at the Museum of Flight in Seattle. However, flying supersonic had its challenges. Due to noise concerns, supersonic flight over land was restricted in many countries, including the United States. This limitation meant that the Concorde could only reach its top speeds over oceans. For the record-breaking New York to Seattle flight, Canadian authorities had to grant special permission for the aircraft to fly at supersonic speeds over sparsely populated areas of Canada. The Concorde's retirement left a void in high-speed air travel. While it couldn't reach hypersonic speeds, it showed the world the potential of faster-than-sound passenger flight. Today, various companies are working on new technologies to pick up where the Concorde left off, aiming to make supersonic and even hypersonic travel a reality for future generations. Could a new era of air travel be on the horizon, where trips from New York to London are completed in just 90 minutes? Hermeus, an ambitious startup company, is working to make this incredible feat a reality. Founded in 2018, Hermeus aims to not only match the Concorde's achievements, but to surpass them by developing hypersonic passenger aircraft. Their goal is to create planes that can fly at speeds over Mach 5, or more than 5 times the speed of sound. To put this in perspective, the Concorde's fastest transatlantic flight from New York to London took 2 hours, 52 minutes, and 59 seconds. Hermeus plans to cut that time by more than half, offering passengers a mere 90-minute journey across the Atlantic. This would revolutionize international travel, making same-day round trips between continents a possibility. The company's CEO, AJ Piplica, has assembled a team of talented engineers from leading aerospace companies like SpaceX and Blue Origin. These experts bring valuable experience from the space industry, where achieving high speeds is crucial. Their shared vision is to bring the innovations of new space, the recent boom in private space exploration, to the world of aviation. Hermeus's first step towards this ambitious goal is the development of a prototype aircraft called Quarter Horse. This unmanned vehicle is designed to break speed records and prove the viability of the company's technologies. The team's ultimate target is to surpass the speed of the legendary Lockheed SR-71 Blackbird, a reconnaissance aircraft that still holds the record for the fastest air-breathing crewed aircraft. To achieve these high speeds, Hermeus is developing its own engine called Chimera. This innovative propulsion system combines elements of traditional jet engines with more advanced technologies suitable for hypersonic flight. The engine's name is a nod to the fire-breathing monster from Greek mythology, reflecting its powerful and hybrid nature. Hermeus faces significant challenges in its quest for hypersonic passenger travel. These include managing the extreme heat generated at such high speeds, ensuring passenger safety and comfort, and addressing potential environmental concerns. Additionally, they'll need to navigate complex regulations surrounding supersonic and hypersonic flight over populated areas. As Hermeus continues to advance its technology, the possibility of routine hypersonic travel gets closer to reality. While it's still some time before booking a 90-minute flight across the Atlantic becomes an option, companies like Hermeus are pushing the boundaries of what air travel can achieve. As people dream of flying faster than ever before, one question comes to mind. How can engineers design an engine powerful enough to reach hypersonic speeds? At the heart of Hermeus's ambitious plan to develop hypersonic aircraft is a revolutionary engine called Chimera. Named after the fire-breathing monster from Greek mythology, this engine represents a fusion of different technologies, much like its mythical namesake combined parts of various animals. Chimera is what's known as a turbine-based combined cycle engine. This means it combines the best features of different types of jet engines to overcome the limitations of each. The main types of engines involved are turbojet, ramjet, and scramjet engines. Turbojet engines, which power most of today's commercial aircraft, work well from a standstill up to about twice the speed of sound that is Mach 2. However, they struggle to maintain speeds beyond this point. On the other hand, ramjets and scramjets excel at very high speeds, particularly above Mach 5, but they can't operate efficiently at low speeds or from a standstill. The Chimera engine aims to bridge this gap by using a turbojet for takeoff and initial acceleration, then switching to a ramjet mode for high-speed cruise. This combination allows the aircraft to take off from standard runways, accelerate to hypersonic speeds, and then maintain those speeds for extended periods. To develop this complex engine, Hermeus took an innovative approach. Instead of building everything from scratch, they used readily available off-the-shelf gas turbine engines for the initial turbojet component. This strategy saved them billions of dollars in development costs and years of time. For their first Chimera prototype, Hermeus chose the General Electric J85 turbojet engine. This engine has a long and successful history, having been used in various aircraft, including the Cessna A-37 Dragonfly and the Northrop F-5 fighter. The J85 has logged over 16.5 million flight hours, proving its reliability and performance. In November 2022, Hermeus achieved a significant milestone when they successfully demonstrated the transition from turbojet to ramjet mode in their Chimera engine. This transition is crucial for hypersonic flight, as it allows the engine to operate efficiently across a wide range of speeds. Building on this success, Hermeus began developing Chimera 2, an improved version of the engine. For Chimera 2, they selected the more powerful Pratt & Whitney F100 engine as the turbojet core. The F100 is used in famous fighter jets like the F-15 Eagle and F-16 Fighting Falcon, and has accumulated over 30 million flight hours in service with air forces around the world. While Hermeus used existing engines for the turbojet component, they developed other crucial parts of the Chimera engine in-house. These include the inlet, pre-cooler, ram burner, and bypass system. These components are essential for managing the extreme temperatures and pressures encountered during hypersonic flight. One of the most critical technologies Hermeus is developing is an advanced cooling system. At hypersonic speeds, the air entering the engine becomes extremely hot due to friction, which can damage the engine components. The pre-cooler technology helps manage this heat, allowing the engine to operate safely at high speeds. In May 2024, Hermeus began testing its proprietary cooling technology with the F100 engine, marking a significant step in the development of Chimera 2. This cooling system is expected to enable the engine to reach speeds of up to Mach 2.5 in its initial tests. The development of the Chimera engine represents a major technological challenge. Combining different types of jet propulsion into a single, efficient system requires solving complex engineering problems related to thermodynamics, materials science, and fluid dynamics. However, if successful, this engine could revolutionize air travel. Hermeus's approach to engine development, combining off-the-shelf components with custom-built technologies, has allowed them to make rapid progress. They built and tested their first Chimera engine for just $18 million over 21 months, a fraction of the time and cost typically associated with developing new aerospace technologies. As Hermeus continues to refine and test the Chimera engine, they're moving closer to their goal of hypersonic passenger travel. While there are still many challenges to overcome, the progress they've made with Chimera demonstrates the potential for significant advancements in aviation technology. If successful, engines like Chimera could usher in a new era of ultra-fast global travel, dramatically reducing flight times for long-distance journeys. As Hermeus develops its groundbreaking Chimera engine, one might wonder, how do they plan to test and prove this revolutionary technology in real-world conditions? Their answer is in the Quarter Horse project, Hermeus's ambitious plan to create a series of increasingly advanced aircraft to demonstrate their hypersonic capabilities. The Quarter Horse is not a single aircraft, but rather a family of prototypes, each designed to push the boundaries of speed and performance a little further than its predecessor. The project is divided into 4 main stages, each represented by a different version of the Quarter Horse: Mk0, Mk1, Mk2, and Mk3. Let's explore each of these stages and what they mean for the future of hypersonic flight. The journey begins with the Quarter Horse Mk0, a ground test vehicle designed to evaluate various systems and their integration before any actual flight takes place. In early 2024, Hermeus announced the completion of tests on the Mk0 at the Air Force's Arnold Engineering Development Complex in Tennessee. During these tests, the Mk0 achieved several important milestones. The team demonstrated their ability to control the vehicle from a distance, an essential feature for future unmanned flights. The Mk0 successfully moved on the ground, simulating pre-flight operations. They tested the speed and reliability of communications between the vehicle and ground control, and assessed how well the vehicle maneuvered on the ground. The team verified that the vehicle's systems functioned properly during simulated flight conditions, and pilots conducted simulated flight operations to ensure the vehicle's controls were intuitive and effective. What's particularly impressive is that Hermeus designed and built the Mk0 in just 6 months and completed all these tests in only 37 days. This rapid development cycle demonstrates the company's agile approach to aerospace engineering. Building on the success of the Mk0, Hermeus unveiled the Quarter Horse Mk1 in March 2024. This version is designed to take to the air, with its first flight scheduled for late 2024 from the historic Edwards Air Force Base in California. The Mk1 is a remotely piloted vehicle, meaning it will fly without a human on board. Its main purpose is to demonstrate high-speed takeoff and landing capabilities, which are crucial for any future hypersonic aircraft. These tests will help prove that Hermeus' technology can operate safely and effectively in real-world conditions. Like its predecessor, the Mk1 was developed quickly, with the entire process from design to completion taking just 7 months. This rapid iteration allows Hermeus to learn and improve their designs faster than traditional aerospace development cycles. Both the Mk0 and Mk1 use the Chimera engine based on the General Electric J85, which provides a solid foundation for testing the company's innovative propulsion concepts. The next step in the quarter-horse project is the Mk2, which will feature the more advanced Chimera 2 engine. This engine uses the Pratt & Whitney F100 as its core, providing significantly more power than the J85 used in earlier versions. In May 2024, Hermeus began testing its proprietary cooling technology with the F100 engine, marking a major milestone in the development of the Mk2. This cooling system is crucial for managing the extreme temperatures generated during high-speed flight. The goal for the quarter-horse Mk2 is to break the sound barrier and demonstrate autonomous supersonic flight at speeds up to Mach 2.5, about 1,918 miles per hour. This would be more than twice as fast as the Concorde's cruising speed and would represent a significant step towards hypersonic flight. The final planned iteration of the quarter-horse project is the Mk3, which represents Hermeus' most ambitious goals. With this version, the company aims to demonstrate the transition from turbojet to ramjet mode in flight, a critical capability for reaching hypersonic speeds. More importantly, Hermeus hopes the Mk3 will break the all-time airspeed record currently held by the legendary SR-71 Blackbird. The Blackbird, a reconnaissance aircraft developed in the 1960s, set a speed record of 2,193.2 miles per hour, equivalent to Mach 2.85 in 1976. This record has stood for nearly half a century, highlighting the significant challenge Hermeus faces. The ultimate goal for the quarter-horse Mk3 is to reach Mach 4, which is about 3,069 miles per hour. While this falls short of the Mach 5 threshold for hypersonic flight, it would represent a massive leap forward in aviation technology and bring Hermeus much closer to their dream of hypersonic passenger travel. As exciting as the quarter-horse project is, it faces numerous challenges. At extremely high speeds, friction with the air generates intense heat that can damage the aircraft. Developing materials and cooling systems to withstand these temperatures is crucial. The Chimera engine must operate efficiently across a wide range of speeds, from takeoff to hypersonic cruise. The aircraft's shape must be carefully designed to minimize drag and manage shock waves at high speeds. High-speed flight requires enormous amounts of energy, so fuel efficiency is a major concern. The noise and emissions from hypersonic aircraft could face regulatory hurdles. Any passenger aircraft must meet extremely high safety standards, which becomes more challenging at hypersonic speeds. Despite these challenges, Hermeus has made impressive progress. Their ability to rapidly design, build, and test new prototypes allows them to iterate and improve their technology quickly. This agile approach, combined with their innovative use of off-the-shelf components, has helped them advance their project faster and more cost-effectively than traditional aerospace development methods. While Hermeus hasn't set a specific date for the Mk3's record attempt, their rapid development pace suggests it could happen within the next few years. The company is closely monitoring its production timelines and the team's ability to meet milestones. With Hermeus making rapid strides in hypersonic technology, what does the future hold for this ambitious startup? Hermeus has garnered significant support from influential organizations and individuals in the aerospace and technology sectors. NASA, the U.S. Air Force, and Sam Altman, the co-founder of OpenAI, have all invested in the company. This backing, amounting to hundreds of millions of dollars, demonstrates the confidence these entities have in Hermeus's vision and potential. The support from NASA and the U.S. Air Force is particularly noteworthy, as it suggests potential applications of Hermeus's technology beyond commercial travel. Hypersonic aircraft could have important implications for national security and space exploration. Looking ahead, Hermeus faces both exciting opportunities and significant challenges. The company's ambitious goal of breaking the SR-71 Blackbird's speed record in 2025 will be a crucial test of their technology. If successful, it could pave the way for further advancements in hypersonic travel. However, Hermeus must also address concerns about the environmental impact of hypersonic flight, ensure the safety and comfort of future passengers, and navigate complex international regulations governing supersonic and hypersonic flight over populated areas. Despite these hurdles, the substantial investment and rapid progress made by Hermeus indicate a promising future for hypersonic travel. If their plans come to fruition, we might soon see a revolution in long-distance air travel. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.